That's the layout we have seen before. I just would like to prepare it again a bit. You've seen, okay, you have a lot of options to do the routing manually. You can have, I don't know, a workshop only about layout. If we would do this, I would prepare some layouts and show you how it's done. So, but I think it doesn't make sense to go deeper into detail. But I think you have an impression how this works. I did not mention the autorouter. That's something we also I want to show you. It's more kind of a show. Now, so if you have nothing routed and you're a guy as I am, say I'm an unskilled layouter, then you could consider to use the autorouter. As I said in the morning, some people use it. They have no fears, no problems in using the autorouter. They use it for everything, and in a lot of cases, it really works. In some cases, you can't use the autorouter, depending on the signals you have, depending on what you're doing. I just want to show you how this works. It's also the easiest way is use the quick route, click onto the signals, and let Eli decide the trace where to go, where to put it. I have the autorouter, that's this one here, and here we are. I have to think about configuration again. The autorouter takes care on the design rules, of course. So you will get an error-free layout. You have to think about maybe routing grid, about how many layers should the autorouter use, and you have to set your design rules before you start the autorouter in a way so that you can be sure that it really works. If you have enough time, then the autorouter will finish with 100%. If you don't have any other problems. Of course, if you have constraints or problems in the design rule settings and you get error messages before you start the autorouter, you can be sure that it can't be done by 100%, of course. So that's what Andy said. You could use the autorouter as a tool to evaluate your positioning of the components. If I start the router and I have, let's say in 2 minutes, I have a result of 20%, then it's probably pretty bad. I can try to rearrange the components, do a second try. If I have in 2 minutes 70 or 80%, then it's better. So you can have a bit of you can estimate maybe this could be better. So before I start the router, let's again back. Let's check the design rules, just to show what happens now. Is the positioning of the components okay? So I've shown you the electrical rule check for the board, for the schematic, and we have the design rule check for the design rules in the board. If I run it, I get again this dialog we have seen before with the design rule settings. I could check them again. I could even change something and say I want to have other values for clearance, whatever. And then I say simply check. Or I also can use a selection of the board. I say select and choose this area here, for example. And then Eagle will check this area. You see, okay, these are not really errors. It tells me there are 51 air wires, unrouted signals. Of course, that's clear. Why does the DSC also tell me that there are air wires? That's a long-term customer complaint that this hasn't been done before. in the design check. So in older versions you had to run a design check. If you have no errors in the design rules, you have to do a rat's nest command to check if there are errors left. And now we put this into one window, because only if the rat's nest says there are no errors left, it says nothing to do. That's the message for the rat's nest command. Then you can be sure that all the connections are done. And if there's one error left, then you might have a problem, because there's missing a connection, and that's the reason why we put it into the design rules. But here we have only errors. I can even expand this, click on it, and it will show me where are the errors. In most cases, if one error is left, it's a very, very tiny, very short piece of error anywhere. You hardly see, and then the design check helps to show where to look for. Okay, nothing, no problems to be expected, so I start the router again. That's your main setup. Now here we have to decide about which layers should our router use. And I can decide about preferred directions. That's also something, no I can't, I did try. You see this characters, preferred direction, horizontal, vertically, 45 degrees, 135 degrees, the asterisk stands for no preferred direction. What does this mean? If I have a two-layer board, then Eagle tries, for example, to have the top layer, I have all the, if it's possible, to have the main direction, for example, horizontally, on the bottom vertically. That makes it easier to get connections. I use vias, go from here to there. So I try to avoid crossings in the traces. Sometimes it can be helpful to say no preferred directions. If we have a lot of components that are BGAs, for example, or they have connections on all four sides, then it can make sense to say, okay, I want to have no preferred direction. I can give you a sneak preview. We have a fan out command where you click on a component and it will get short wires, traces out of the command, of the component. If I leave everything as it is, Eagle will decide and say, okay, I'll try different settings. There is a kind, this effort setting is quite nice, because so I tell Eagle, okay, invest more or less work into the routing. This means Eagle will create a set of routing variants, a set of different settings, and then we will route all these variants more or less simultaneously. That's the reason why I have this maximum number of running threads. My computer has 8 cores in the CPU, and so I have now chosen 8 threads simultaneously. I wouldn't do this because if you really run an autorouter, it occupies your computer. You can't do anything else in a reasonable manner. So I would limit this maybe to some cores. I could use this auto grid selection. So Eagle decides by itself, I take this and this grid setting. I also could switch it off and say I want to have a certain setting, which could make sense if you know the board here. I would take just an example, 0.1 millimeter, for example. And then we have a variant with top router. There's also a crazy story behind this. We have this, we call it now the classical or traditional autorouter, which we have invented, I think, 20 years ago, which is still running. It's not so bad. And we have a totally new router in the Eagle software, a so-called topological router. He uses a totally different algorithm to find its path through the board. The old router is based on an algorithm it's the Lee algorithm from obviously a Chinese. I think it was 25 years ago when this was introduced or invented. And the new router uses another approach, which is based on Voronoi algorithms, whatever this means. Totally different approach. Let's run it. We have seen that the top router is better in dense boards, but in most cases it takes longer time until it comes to a result. But the result is not so bad. Okay. If I click on to continue, okay, in this case, because I decided about the grid, I only have 3 variants. I can see the parameters. If we go there, you see there's a number of parameters behind. The top router does not use preferred directions. Here we have top vertical, bottom horizontal. I think that's the other way around, correct. I have the grid here. And there are a lot of settings. I don't want to go into details. This Lee algorithm says every step in the board costs you something. It's like driving on the motorway or whatever. So you have to pay for each step in the board. I have a preferred direction. If I go into the preferred direction, I have to pay 2 points or whatever. If I have a deviation, then there's a non-pref. Okay, in this case, go there. I get 1 step costs me 5 points, and so on. So I get a cost for my path, and even or the router tries to take the cheapest one. That's leave it as it is. That's the best way. There are some situations where you can change something. That's the 2 cases. These are written in the manual. You can read if you need. But I think the outer router gets more and more less important. We have the new tools, manual routing. When the top router was finished, we said, okay, we have to have this and that improvement. At the moment, nobody cares about this. There's no investment at the moment in outer routing because the doing it manually, quick route, push and shove, and all this stuff. I think it's finally more efficient than what we are doing here. Because here I have to blindly set some parameters, then I start the router, and if you have a complex design, it might happen, it's a calculation of hours or a day, if it's really complicated. After a day you have 7 variants of your board, and all of the variants are not what you have expected. So you start again, try another setting, try other things, I don't know, rearrange the components, whatever, and then you go on, okay, maybe you finally have used 2 days to get the result, and you say, okay, now but I have to do some cleaning up, and during this time you do it manually. With the new tools you can do it manually at the same time, or even quicker. So I think the tendency or the trend is going less auto router, more manual, automatically supported routing. Something like this. Okay. Yeah. If we run this, let me minimize this window again, and I simply say start, and now it starts to process all the 3 jobs simultaneously. You see there happens something, you can look and watch it. I can switch from here to there. Also the top router is working, and when this is done, all are completed. Now you see top router. You can look at the results, and what I do not like is something like this. I have 90-degree corner, 45-degree corner. That's not nice. So you can choose one of these. I can select one and say end job. Then this would be the final result. I could also go into this one and say evaluate. So I look into this board. Now I'm in the editing mode. I could look around, move around, whatever. And if I say, okay, that's finally the thing I want to have, then I could click here. I can say end job and then this one's where it's like. So yeah, it's a quick solution. If I would have done a bit more in investment in design rules, and what I did not yet mention are net classes. You see the outer takes the 150 micrometers from the design rules, and all the traces have the same size. I could define net classes and say my ground net has to have this width, these nets have to have that width, so I have different width values for this. Then I could, the autorouter would follow the net class settings, and then it's a bit more not so simply structured, I would say. But yeah, okay, that's the result. So it's a quick solution. Sometimes it works. I wouldn't use it for this. And what I do not like is doesn't look nice. No, it isn't. Of course, you can play around with the parameters. This helps, but you have to invest a lot of time in fiddling out what makes sense, what not. For simple boards, quick solutions, yes, okay, you can use it. For first design, for evaluating something, why not? But that's my personal opinion. Autorouter is nice, but I can do it better manually, I think, at least. Of course, I could, after this is done, I could use the root command again and try to smooth this more a bit. Click on this, but you see, yeah, it's not so bad because there's hardly something to promote here. No? You say it is okay. Yeah. Yeah, it's yeah, there you get some, but I don't know if this got that. Okay. But you see how it works. Basically, that's how we use the autorouter. You could also start and say select only some signals. Maybe you route ground or the power supply and the power signals, and I want to do the rest manually. Or you can also do a combination of both. Route something manually and let the autorouter do the rest. Also, this is possible.
And how do you do that? How do you do that?
Simply route, go back, do a rip up. I do some manual routing.
Yeah.
No. Okay, this could be routed. Okay, so I have some stuff here,
Yeah.
and now I simply start a router. And all
Just leave those as these.
the signals that are already there, they will remain untouched. So this will remain as it is.
So you could route your critical ones and then
Yes.
if you're less fussy
Yeah.
about the rest
For
of
sure.
it, let
Yeah.
them also route.
Yes. But it's also, it depends. If the layout is sorted in a way that you say, okay, my critical signals, they're all in this area. And for the autorouter, it's quite easy to do the rest. If we have signals that go straight through the board, from here to there, it could be complicated, more complicated. But yeah, people are doing this. If you combine it, then you do your stuff before you start out. Because then I have this what I want, and all the unimportant things I leave the autorouter.
I was kind of doing it the other way when I was expecting with it, because I knew that I wanted to route all my power by hand, but I was still at the stage where I was trying to move components around to the best placement. So after I found that if you start the auto router for the command line, you can then exclude various nets that you don't want it to touch.
Yes.
And that was really useful actually.
Yes, that's also possible.
Yeah.
That's true.
Yeah.
You can start a router. You can also do it with the menu and say start it, and then say select. Now I could type the names I want to have, or I can also exclude some of the signals.
Yeah.
or I can click on it and say I want to have this one routed.
Oh, okay.
And just start it.
Yeah.
Yeah, that's true. You can do a combination.
Sure.
Sometimes makes sense. Yes,
Yeah.
of course. Yeah, that's something you have to decide or try. And if you have good experience, you will do it again. If you have bad experience,
Yeah.
then you won't do it again. So those depends on the
You just
Okay.
have to play with it.
yeah. So let me reload the file. No, I don't want to reload it. I have to. Let me see how far we can go back. I delete this. So before the output, okay, I'm back here. Okay, no, that's not what I want to do. Okay, leave it here. That's okay. If you want to find, for example, here again, here you see the design manager. It could be quite helpful now because I know which signals are in. I have a ground signal for example. Here, it's in this area, so it's a small area where I have ground. I have different grounds here, digital ground in this area. What I want to show you as one of the things in the layout, I mentioned the polygon command in the beginning, and I would like to have, let's say, digital ground connected to a copper area, copper plane. So therefore I use the polygon command, this one. I have to decide about in which layer do I want to have it, and I have to decide about the width of the polygon. So I should tell you why you have to decide about this. And then I simply say in this area from, let me change 90 degrees. In this area I want to have my DGMD, this one. Then it immediately asks now for the name. I say DGMD. Yes. Okay. Here we are. Now it's a dotted line that tells you that's a polygon. Nothing happened yet. And now I want to have it calculated. I want to fill it. And therefore I use the rat's nest command. That's the same command we use for calculating areas. Click it and it's calculated. And what you see now is, for example here, this one, you see this pad is connected to my ground plane. And all the other signals are isolated. So that's automatically calculated. Here as well, connection. Here and here. Here, for example, yes, that's the connection. You have to decide about a wire width for the polygon, because Eagle fills the polygon with small wires in the width. There's overlapping a bit, and so we fill all the whole area. And the width for this polygon also decides about the thickness of these connections here. If I would make it smaller, yes, then the connections will be smaller. And my recommendation is use a value or the same value as you use for your traces, so that it fits. And this area we don't have copper. Why? The whole polygon now is connected to the digital ground, and I have no digital ground here, so I don't connect it. I can't fill it. There are different settings, different modes for the polygon, where I also can say, okay, fill also areas, so-called orphans, inside my contour that are not connected to DGMD. Sometimes it makes sense, in most cases I think I wouldn't do it, depends on the design. If you ask a board manufacturer, they like it to have a consistent copper area or copper on the board. If you're talking to high frequency guys, they say copper areas that are not connected to signal that can work as an antenna or something like this, you can have problems maybe or not, depending on what you're doing. So just to show you, I can switch this in the properties. How do I get this polygon again? Because if I click there, of course I don't get a polygon with the right mouse click. I have to click in the area where the contour was, anywhere there. If I don't find it, then I would recommend to switch it back into the outline mode. The easiest way to do is use RipUp. There we have this one, all polygons. And now I'm back in outline mode. Now I can do a right click, go into the properties, and there we have, for example, the orphans. Switch it on now and say OK. Let it calculate again. Where is it here? Now you see the whole area is filled, but there are areas inside the polygon that are not connected together. So that's also a problem of the design you're doing. And here again, the designer has to decide what's good or what's bad. That needs electronic skills and understanding what are we doing here.
So, for example, one of these orphans, maybe this one or this one, that have got a track underneath them. You might want that orphan connected to the ground to provide some shielding. Can you just drop a viewer and connect it to ground?
Yes, you could do.
Yeah.
Yes, you could set the viewer. Okay, I have no ground here, but I could of course set the viewer. I could place it first, or I can also directly name it EGLD. Place it anywhere there. Here it is. It's inside. It goes from 1 to 16, and so I could connect whatever. So that's possible. And you very often see high frequency designs that you have to terminate your not this way, but you terminate the ground plane against your signals. It helps in having a good noise behavior and so on.
Sorry, I hadn't seen that before. When you initially did that, you selected VIA, and then you just typed the signal name in the box up there.
Yes, you can directly name the VIA. I used a single quote to tell Eagle that's a name which is running. I think it's not necessary to do there. It depends on the options that you want. Let me try and say TTT. Invalid option. So I have to use a single quote and then the name, and then it's named this way. If I place it here and I would do a red's nest again, then you see it's isolated because it carries another signal. Okay. So that's about polygons. So you asked for the meanders. So should we try it just to show you? Can do. Okay. So if I would like to have two signals with the same length, I don't know if that's a good example. Okay, let's go back, but that's not so bad. Just let me prepare it. Where is the origin? Here we go. Okay, doesn't matter. I have to define a differential pair. That's done by the signal name. I have signal name underline P or underline N for negative and positive. So I will prepare this. Let's try this one. I click name and name it 1 underline P. Okay, I don't know if it works properly, but I will try. And then I name this 1 underline N. So I have a differential pair. Now I have the root command. Go there. I think the walk around obstacle, I think it doesn't work for differential pairs. But I click on one of these signals now, and you see both come to my mouse cursor. Can decide a bit how to come out here, and doesn't make sense now, but just to show you. And then I go on and route my way through the board even if it's looking like this, if I click, the display is corrected. Oh, I have something like this. So go up here, go there, go there. So there are my target pads now. Now I have to drop one of the signals. I simply use escape. One of the signals drop off the mouse cursor. I finish this one, and I finish that one. Okay, that's what I have here because I have a number of, but I can drop it with escape because this continues. I just want to use this one, go there. And now I have, if I would have defined red class, then I could decide about width and clearance and so on. And now I have the meander command, which is here. And now I can click on to one of these signals. And it tells me, okay, the total length, it's really total length is 32 point something millimeters. And the other one is 90% of this 100 millimeters. And what I can do is now I simply move the mouse and I get, okay, that's a symmetric mode. It doesn't make sense. I change the mode here with the right mouse click and I get something like this. And you see simply the moving the mouse, as moving the mouse, I get something like this. And now I have the same length. Very easy example. Of course, I could also add meanders on different locations. I could also go in there. And, okay, it's not possible because I have 100%, but I could split this as well. And so that's the way how I could do a length balancing in the eagle. You could also, if I have different signals, route, quick route, this one, yes, that one, oh, different layer, interesting, okay. I could use the meander command here, click there, I see that's 36%, and now I have to use control, no? I know, what I wanted to show you, yes, I can define a certain length for this. If I click here, I say, okay, it was 24 millimeters, I want to have 30, I simply enter 30, meander command is active, enter, and then I click here, and then I try to get the meander, and I get my 30 millimeters. That's something, it's dependent on the grid you have set in the layer editor. And you have this gap, the gap factor in the design rules, where you can decide about how tight is the meander. That's the way you can do it. Okay?
Yeah, thank you.
Okay, cool. That's working. Okay. Yes. Let's check. Coffee break. Okay. Yes. Finally, last step for today. If the layout is done, it's not done yet. So what can we do? We could try to run the output again. Let's see, maybe it's possible to finish it. So I just say continue. Not enabled. Ah, yes. Yeah, that's true because now I have one trace in one of the inner layers and the output says, hey, there's something inside, should I take care of this or not? I say yes or no, I say yeah, go on. Start. Ah, you see, okay, and then we have 100% here as well. So that's already done. Top router. Yeah, see, in this situation, the top router has 13 layers. The others have some more. Okay, so we decide for one of these options. I don't know. Let's say add drop. That's it. The polygon has simply to be recalculated. Now let's run the design rule check again. That's the final thing you should do. Run the design rule check. I have 2-dimension errors. Let's see why. There. Okay, I routed through a mounting hole. That's something you should not do. It's the same error. 2 messages. Sometimes it depends on the layers that are effect that you get one or possibly 2 or 3 messages at the same location. So what I do here, I don't approve it, I would quick fix and say, oh, move, here we are. That's also something new. The move, we keep the angles persistent. We try to have the angles in 90 or 45 degrees. So I change this. I do a save. I run the DSC again to check if there are any other problems. It says no errors. I could also do the rat's nest command again. And that's the message I want to see. Nothing to do. So if rat's nest says nothing to do, everything is rooted, we can hope that the board will work when we get it back. And now the last step, I save it, and then I just want to show you, you could simply use the board file now, send it to the board manufacturer, or you create your manufacturing data by yourself. Therefore we have 2 tools. It's one tool, it's the CAM processor, but we have 2 ways to use it. There's the quick one, it's generate CAM data. I click onto this. Eagle tells me I will create all these files here. Drills XLN, okay, that's the XLN file, drill data. I have something for output job. That's the job file. I have the top layer, I have inner layers, I have the profile. That's contour plus milling contours if there's something. I have solid mask for top and bottom, I have solid paste for top and bottom, I have silk screen for top and bottom. That's usually a 4-layer board, components top and bottom, so that's what I do. I say, okay. Yeah, I have to look at it, it's not possible to. Okay, that's it. I say, Eagle tells me, okay, I make a zip file, that's it. Save, and then it's done. And this zip file, this one, I can send to the board manufacturer and they create my board. That's the quick way to do it. If you have some specific settings, then you could do it a bit in another way, not so quick. I go and use simply the CAM processor. Here I am. Again, I have a template for 4-layer CAM. It's basically what Eagle decided to do before, but now I see I have the Epsilon here. I could maybe decide about should be the units metric or imperial, what about the format and so on. So I can do some changes if I want to. That's the Epsilon output from layer to 16, include years, PTH, dual components, pads, mode, and holes. And that's the output file. I have some advanced options. I can mirror the outputs and so on. So that's usually okay. Maybe if I print something or do it manually, some people etch their boards at home in mother's sink, wherever. And you have the Gerber files, Gerber X2 again. I can decide about the units again. Format specifier, top, you see all these files that are created. I can add a description and so on. And if I say process job, we get basically the same what we have done before. So that's about creating manufacturing. So to say, you don't have to take care of anything in a regular usual board. Of course, there can be some special things if you use maybe your own layers. Because you have drawn something, you want to have a special logo printed or something like this, you have drawn this in a user-defined layer, then you would add this here into, simply do a right-click here, add a new Gerber output, set which layer should be output, in which file should it go, what device you want to use for and so on. That's one thing. If you have old stuff, CAM jobs from previous Eagle versions, you could do this here in legacy. I can go here and say delete all. That doesn't mean I delete the files. I just delete the job and say I don't want to have this output. I have a legacy job from my old version. I go there, right click, open legacy CAD job. I have to find one. I go to 7.7 just as an example, it doesn't matter. I have also in the new version CAD. Take this one, middle drill, open. So I have the, as you know it from the old versions, the old stuff. I can also convert this into a new JSON file if this is something you would like to do. So you see, I have all the this stuff as I had it in all the versions. I said some people have a real process. The whole process is around legal, and so we can't change this. So we support all the old stuff. It's a bit different to use now, but we support it. So you can work with the old jobs as well. Click process job, and it's done. And you get the files and send it to one manufacturer. Okay, so that's what's called. So that's about GAN processor. That's very easy. And you have seen in the you have a preview. Just to go here again. That's how the Java file looks like. What's inside? If I would export this, there are free Java viewers we can look into. It looks the same as it is here. I don't want to know the details here. That's the one thing. And then there's something. Maybe I make a sneak preview for tomorrow. There's this manufacturing tab, and this gives me a manufacturing flyout. And there I see the manufacturing data as a preview. I can also go this way and then I can start the CAN processor. That's what I can do basically here. And that's the look through the glasses of the board manufacturer. You already have the manufacturing data here, and you see it. That's the way how my board will look like. It's very simple. I can look top side, bottom side. I can look into the drills. So that's the drill file. I could export the DXF here. I could also export an image. Then it looks as you see it here in the preview. And what's also quite nice is I can change the colors. The colors are not important for the board manufacturer because that's something you have to tell him, but that's something I can use for Fusion. I can decide I don't want to have it in green. I would like to have the, what is it, background color, no, the substrate color. I would like to have it in, I don't know, blue. Say okay. Okay, it's not a nice blue, but it's a kind of blue. What's here, I think that we have that's the polygon. So I can change.
It's a solder mask.
Yeah, I can change the solder mask as well, just to make a bit of nonsense here.
Yeah.
That's the solder mask. Yeah, correct. Substrate is the printed board itself, and this one is the solder mask. Yes. And so that's if I save the board now and push it into Fusion, you will see it in this color. The live update, it's even, one more. One of the developers played a bit here and he says, okay, if we go here, I see some properties, statistics about what's the board area, width and height, what's the stack up, 4 layers, what are the components, how many are there, so we have a bit of statistics inside. How many pads? What are the pad density? That could be quite interesting sometimes for the board manufacturer to see what's this all about. Number of drills and so on, the sizes and so on, and the routing. What's the routing? Number of signals, minimum copper trace width, for example. So we see some basic information. And also what's quite nice is we have a table of the drills. I can click on it. And I also can click here and say, show me the drills. I have to highlight it. This one, that one, 5. I can even think one after the other here on the right hand side, you see. Sometimes it happens if you have a board and you run the statistics and say, hey, I have 25 boards, 0.8 millimeters, and I have one not more, one drill. And I have one drill with 0.81 millimeters. There is it. And then I can find it out because I think there, then we see, that's the one, maybe I have to change. So it's quite nice to have. And you can also export this table into a CSV or JSON file. So you have the statistics and you can pass it on to anything. Okay, so done. Save. Last act preview for tomorrow, Fusion 360. I would like to push this now into Fusion. I don't know what happens because we didn't make it. I create a new Fusion design next. Now it connects to my account, my Autodesk account. I have also Fusion there. I have some projects. I have a lot of first projects, so I take this one and say okay. Okay, that's a pity because we don't have, there are no 3D models assigned. Doesn't matter, so you will see it tomorrow. Now I say push. Okay, what happens? Eagle collects all the data it needs to make a step file. If there would have been 3D models linked in the libraries, then we would see 3D models being displayed. I don't have it here, but just to show you, it's okay. It's quite. I feared it would last a bit longer. It says okay, it's there. I can view a map. What happens now? I come into my account. That's Fusion team here. What we see. It speaks German to me. And now it collects the components to display. Here we are. You don't see very much because I have no components defined, but you see the board at least. I see that the copper plane is not very good represented. That's something they're working on because it should of course not be there. It should be cut out as well. This is the place where we usually would say, okay, that's my step model. I could share it with other team colleagues here. This preview, they could look into it. You could do some markup, do some commands or whatever. Let me go back on there. Maybe I can show you something that's more. This one. That's not too bad. It's already uploaded some time ago. Yeah. So you see, for example, that's something I've done. Okay, it's not the final version. You see here, I have some components. If there are no components designed, you get a kind of bar block. That's an old project that I designed 1,000 years ago. So that's basically the first step. What I can do now, if I don't want to use Fusion or I don't have Fusion, I could go there and simply export in any format. I could use STEP or STL for 3D printer or XL for EDG or for Inventor or SketchUp. Do you know SketchUp? The great projects with Eagle. That's really photorealistic display of such layouts. Yeah, that's what I would like to show you tomorrow. Tomorrow it's, I think it's a bit more relaxed. Because you see that the ICs do not fit. This was one of my first tries to get this board in 3D. I should have it anywhere. Let me go back. It's not.
Richard, could you edit that in the desktop version of Fusion? You know, if you've not got the actual Fusion,
Sure.
could you actually? So when you've actually got the board in.
Yes. No problem. I show you. It's already Fusion.
So I know you've got like the basic modeling.
I only have to start Fusion, then you can see it because it's already there. It's on.
Sorry, I meant the totally online version of Fusion. You know, the one that's in the cloud. It's just the model.
Yeah.
Yeah.
So that's the full mode. It's a battery charger. Okay. Fusion. But that's what we will discuss tomorrow. If you start Fusion, you will see all the stuff is already there. So as soon as I push it into the web, onto Fusion Team or into the cloud, how you would like to call it, it's already there in Fusion because it's the same data format. I don't have to do any conversion, and I can push it back and forth. That's what we will see tomorrow. The only thing is, if you have a good internet connection, everything works perfect. If you have a bad internet connection, you're sitting there and waiting. And I consider this as a good internet connection, and it's slow. It could be much quicker. Okay, so here I am again. I have to choose the right project. I think it was this one. Yeah, here it is. That's also a thing that's new, but I will show you tomorrow. That's how it looks like in Fusion. Here we are again. So, idiot. So, no, I won't. No. So you see, that's looking the same. And what I can do in Fusion now, that's something we try tomorrow. I could remove a component. I could change the board size, the board contour, and then I can bring it back into Eagle. And I can do some changes and have to do some measurements. That's going in both directions.
So, for example, if you want to take that rather boring rectangular board outline into a fancy profile like a circular one,
Yeah.
fit the case or something, you can edit that.
You can basically you can design your project in Fusion and say, okay, that's a fancy contour.
Yeah.
This I consider as a PCB object, and then I push it, or I put it from Fusion into Eagle.
Yeah.
And then I can use this. Let me see, maybe I have something. Maybe inside there, but I will clean up. Yes, something like this, for example. Now this one, this is something I designed. Not designed is said too much. That's something I draw in Fusion, and then there's a way to create to make this a PCB board. I do not know how this works. It's not a simulation. It should be in solution. Where is it? I'm in the sketch now. Yes. Okay. I don't know if I click finish PCB, what happens? No, that's not. Okay. We will try
Sure.
tomorrow.
Yeah.
So that we can see how we can do it. But okay, the nice thing is also, not the nice thing, but I know our customers know that they say I don't want to use Fusion because I have whatever SolidWorks, I have Inventor, something like this. Then you can say you get this preview in Fusion Team. This is not yet, but will be part of the Eagle entitlement soon, so you don't have to pay for this. At the moment, I think you can use it for 90 days for free or something like this, and then you have to pay for it. I'm not sure there's a time limit. It would cost about €100 a year to use Fusion Team. As I said, we will have this in Eagle. The entitlement of Eagle will also allow you access to Fusion Team. And then you can go there, export a stat file, and use it in any other tool if you want. But of course you don't have this bi-directional stuff, so you have to export it. If you do changes, of course you have to try to bring it back. There's something, it's called AnyCAD. You can transfer a lot of formats back into Autodesk products, or if you have a step file, Fusion can import step again. Then I can maybe bring this back into Eeview, but it's not so convenient. So you have to do a lot of conversion, and yeah, that's basically what we have at the moment. Okay. Any questions? I think it's enough for today.
That's great.